Hey there, class. So we're going to briefly talk about Lewis structures and what happens when we can no longer use these puzzle pieces as we've been used to using them. So let's take an example of the molecule CO2, and we're all very familiar with CO2. You will commonly hear it associated as a greenhouse gas, and we typically know that higher levels of CO2 contribute to climate change and global warming, these issues that we're probably pretty familiar with. And it's to say, let's think about, okay, well, what would the structure be for CO2? And you see here, there's something wrong. And in trying, you can arrange these oxygens and carbons in any way that you want. You can try to arrange these puzzle pieces however you'd like, and there's no way to get them to work, right? In this case, what we've got here in putting these together, oxygen has 1, 2, 3, 4, 5, 6, 7 electron pairs. Same goes here. And then carbon only has 6. So this is not satisfied. Remember, we want everything that's not hydrogen to have 8. That's a requirement for us. So the way that we're going to move on from this is to come up with a new set of rules that will work for any molecule that we have. And so these are our rules. We're going to find the elements in the molecule that we need. We're going to count how many valence electrons each element needs, and then find the total number. We're going to draw a Lewis structure with only single bonds and lone pairs. We'll count the number of electrons, and then we will add bonds until the number of drawn electrons is the same as the number of valence electrons. So let's put that into practice. So let's say we take the molecule CO2, right? We're going to have 1 carbon and 2 oxygens. Carbon's here, oxygen is here. So carbon has 4 electrons. Oxygen has 6 electrons. And we have 2 of them. So we have 12 electrons. So the total number of electrons is equal to 16 electrons. So the trick is then to say, okay, we're going to first, now we found the total number of electrons that we need. We're now going to draw a Lewis structure with only single bonds and lone pairs. And we're going to count the number of electrons that we've drawn. So let's say we put carbon in the center, and we put a single bond to oxygen on either side. And then we're going to fill in all the lone pairs. Remember, everything has to have 8 electrons. We want to make sure that that's what we're at. So if we draw them like this, every single molecule has 8 electrons. Carbon is sharing 2 of those with oxygen here and 2 of those with oxygen here. And then these 2 complete the 8. Same goes with oxygen. It's got 6 electrons here, and it's sharing 2 of those with carbon right there. However, if we now count the number of electrons that we've drawn, let's see. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've drawn 20 electrons, right? There are 2 electrons hidden in each of these bonds. And we only have 16. So that violates our rule. We only have 16 to work with, so we need to do something different. And the way that we're going to do different is to add bonds until the number of drawn electrons is the same as the number of valence electrons. So remember, when we're drawing bonds on our structure, this means that these are being shared between those molecules. So, or rather between those atoms. So if we draw out our CO2 again, now what we're going to do is we're going to add a bond. So instead of having this, we'll have that oxygen and carbon are now going to have a double bond between them. So now oxygen still has the 8. It's still sharing 8. So it's got 4 electrons in lone pairs and unpaired electrons. And then it's got 4 electrons that are in that double bond. Remember, 2 electrons per bond. Carbon is sharing 2 with oxygen over here, 4 with this oxygen over here, and then it's got those over here. So we've got a total of 8. Carbon is happy. And oxygen as before, 2, 4, 6, and 8. It is also happy. However, now we're going to do the lone pair count. 2, 4, 6, 8, 10, 12, 14, and then this has 4, so it's 18. And again, we only have 16 electrons. We're still too high. So we have to add yet another bond. This is what the rule tells us. Okay, well, let's add a bond over here then. So now we have 2, 4, 6, 8, 10, 12, 14, 16. And we are good. We've solved the structure. The number of electrons available to us, the number of valence electrons available to us from what we saw here, carbon having 4, oxygen having 6, is now satisfied. We've only drawn 16 electrons. we only had 16 electrons, so this is the structure that's going to work out, and you will find that that's the case. Carbon exists as a molecule that has a double bond to each of those oxygens. Each of these oxygens has 2 lone pairs. We call these unpaired electrons lone pairs. Carbon has no lone pairs. Carbon only shares electrons in its double bonds. 4 electrons on each side, or 2 electrons per bond. And that's it.